This video is the first video in EVPN VXLAN, and in this video we will just take care of setting up the underlay network with the BGP and with OSPF. And as we know that to do EVPN VXLAN, first we have to do the underlay network, then we have to do the overlay network, and on the overlay we will be having EVPN as control plane and VXLAN as the data plane, and the connectivity of different servers on the different leaf nodes, and we will see everything in action. And let's start by configuring the underlay network first by using EBGP, and then by using OSPF. But technically the output, what we really want to see, is the same. I mean, we should have the reachability of the loopback interfaces of all the nodes. So in this video we'll just be taking care of these 5 nodes. This is spine 1, spine 2, leaf 1, leaf 2, and leaf 3. So what I'm planning to do is that once we have set up the underlay, the overlay, on top of the overlay, once we have the VXLAN working, at that time we will definitely talk about the EVPN VXLAN route types and how they're propagated, and because once you have walked through all these configurations, you will have a good idea that how things are working. Definitely it's not something like a very complex or kind of a rocket science. So let's get going. Basically what I've done is that at the moment spine 1, spine 2, leaf 1, leaf 2 are already configured with EBGP, and leaf 3 is just left to do the configuration for EBGP. But what I will do, that I will just show you spine 1 and leaf 1 and just give you the components of the configuration. First thing, I'll show you the routing options. And in routing options we have done export in the forwarding table of it's a policy. It's just named as LBPP, load balance per packet, just to give it a name. And if I say show policy options, policy statement, LBPP, so it's just doing the per packet load balancing. And why we need the per packet load balancing is that I'll just hint that out once we are looking into the routes coming from the leaf to another leaf. Then you will really see that how exactly the load balance per packet is kicking into action. So let's see the configuration of BGP. So it should show protocol BGP. It's fairly simple. We have just created a group. The group name is underlay. There is an authentication key, and in this group you are basically exporting your loopback. Your local AS is set to 65001, and take a note of this particular thing. So basically, I mean, if you're doing the EBGP configuration, and here I show you the load balancing per packet. So these two things combined kick one thing into action, which is called ECMP, equal cost multipathing, which is kind of the like a basic thing for the EVPN VXLAN to work without having problems to look into different paths. Okay, so here's the configuration. You're seeing you've got this is leaf 1, this is leaf 2, and this is leaf 3 fairly. And if you look into the configuration of spine 2, it's very well the same. Show protocol BGP. There is a group named underlay. It's just a name. You can give it any name you want to. There is an authentication key. There is an export policy. Its local autonomous system number is 65002. It's again doing multipathing in multiple AS to do the ECMP. And you can see the policy options, policy statement, load balance per packet. And you must be wondering that where is this policy, actually where is this export happening, and it's very well the same. You can see the same way you can check export loop. So in here you're checking from the direct protocol, and you are doing a route filter, and route filter is exactly the same for the loopback of every device. So on this one, the loopback is show interface loopback 0. Here it's 100.2. If you go back and try to look for spine 1, show interface loop 0, it's 101. And if you can say show policy options, policy statement, export loop 0, and you can see that it's the same. So basically the same kind of policy is done for all the spines and all the leaves, and that is what is just doing that. It is it's advertising its loopback 0 interface into the EBGP, and actually to set up the overlay, and later to do the EVPN VXLAN, the virtual tunnel endpoint sources. We should have the reachability to the loopback interfaces of all the devices which are taking part in the EVPN VXLAN topology, be it a spine, be it a leaf. All right. And here is a leaf again. So show protocol BGP. It's very well the same in the C++ way. You can do display set too. So it gives you the same configuration, but in a different format. So whatever you like to, you can do that way. The addressing again I've done basically /30, and that's pretty much it. There's nothing much complex. The same two policy options, the export loopback 0 and the load balancing per packet, both the same policy options are very well here. So let's go to leaf 3, which is not done for the BGP. So let's have a look here. Show policy options, and right now we just have got the load balancing per packet policy options into place, and this is very well shown into, it's exported into routing options. In the forwarding table you are applying that policy, that forwarding table is doing the per packet load balancing. So say show protocols, and at the moment we just got the LLDP running, and but the BGP is not very well in place. So we start with that, edit protocol BGP, and we can say set group. We named the group as underlay. You can name it whatever you want to. It's not something like it's not necessarily. I mean, you people know how does it work. It's just a name and nothing else. So in the group underlay, you say that my local autonomous system number is 65013. I mean, actually, while I've done the configuration in spine 1 and spine 2, I have told them that the leaf 3 side has got the autonomous system number as 65013, and if we are not going to configure it as 65013, definitely we'll have errors appearing on the BGP. And what else? On the other side, if you have noticed, we had set up a authentication key, and that authentication key is JNCIE. And okay, what else? Let's see what is there. So you have got a group which the name is underlay, the authentication key is this, the local autonomous system number is this, and then you can go and set up the neighbors. And what are the neighbors? Really? I don't know. So let's check. All right, so the other side is number 9 and 21. Okay, so set group underlay neighbor 172.16.1.9 and the peer AS. This IP address 172.16.1.9 is on the side of spine 1, and the spine 1 autonomous system number is 65001. And for spine 2, the autonomous system number set is 65002, and the IP address on that side is 192.168.1.21. So here we are. Okay, so that's pretty much all. I'm just leaving one small thing purposefully that I'm not configuring, and I will basically try to show you the difference. So let's commit check. Is it gonna commit? And wow, it is very well there. So I say commit, and then let's wait for the BGP peers to come up. All right, top, run, show BGP summary. Well, still active. All right, so we got our peers up. You can see that in the BGP summary you have got one group, you got 2 peers, and there is no down peer. And you are getting some routes. Okay, so now let's check run show route, and you're learning some routes via BGP. The other way you can do is that you can do run show route protocol BGP, and in the BGP protocol you are learning some routes. One is from spine 1, dot 2 is from spine 2, dot 11 is from leaf 1, and looks like that we are not learning a route from leaf 2. Fair enough, not a problem. So let's go on leaf 2 and see if the peering is very well up and we are advertising something out. Run show BGP summary. So we have the BGP protocol very well established. We have just one group, we have 2 peers, and peers are there. So what's missing? Aha, did you see something? We are not exporting anything. Okay, so see the policy options. Did we do the policy for the export loop 0? We did. So let's do the export. Set protocol BGP group underlay export, and what is the export loop 0 policy, and yes, commit it. All right, so while it's committing from the leaf 2, we go to leaf 3 and we try to check that if the route has reached here, and we have very well got it. Okay, so now if you say run show route 192.168.100.12, so you are getting it from two of your interfaces. I mean, technically, basically, you're getting it from spine 1 and spine 2, and you should be doing the ECMP. So if you want to check that are you really doing the ECMP equal cost multipathing, or is it really there or not? So I'll say run show route, basically the same thing, and forwarding table, and the destination is the same route. And I see that actually I'm just parsing it via X001, so I mean I'm actually going there just by one interface, so fairly there's no equal cost multipathing happening. So we got something missing. Let's check on leaf 1. Do we have the same thing or no? So we can do run show route protocol BGP. You are learning 1, 2, and 12. Did we miss on 13? Let's check on 13 first. That did we advertise the route in there or not? Show protocol BGP, and again we didn't have an export statement here. Show policy options. We actually didn't create an export statement here. Okay. Show interface loop 0. You have this loop back. Set policy options, policy statement, and you can say the policy statement name just to keep it uniform. I'm seeing here it's exports LO, and the term is loop 0 if it is from protocol direct, from route filter 192.168.100.13/32. Well, we need to tell if it is exact or less or more, and then we say accept it and set protocol BGP group underlay, and in this group we are exporting the export loop 0. So if you do show compare, you're basically just adding this particular part, and in the group underlay your export loop 0, just adding it. You commit it, and meantime we can keep on checking something here. So you are getting a route, it's 192.168.100.12, which is from leaf 2, and if you want to do run show route forwarding table destination 192.168.100.12, and if you do check this thing, for this one actually you are doing the equal cost multipathing, but on here we tried to check something before, and we were not doing the equal cost multipathing, and again looks like we did miss or mess something. So show protocol BGP, maybe display set this time. So let's try matching something. Hey, so we are missing a statement which is called multipath multi-AS. So let's just apply that. Set protocol BGP group underlay multipath and multi-AS. So this thing is basically trying to consume destination you're learning from different autonomous systems at the same time. So you can do, I mean, it's the same destination if you're learning from two AS paths. So it's basically overriding the default BGP rules, and it's letting to install both things simultaneously in your BGP. So let's commit, and then we'll try to see the difference. Okay, so let's go back and try to see. So now you see the difference, that once you have the multipath statement very well in there, then you can go to the same destination from two of your interfaces. So this was pretty much it for setting up underlay network for your EVPN VXLAN setup. So this particular thing, maybe you can just you can say it that we were trying to set up IP fabric, and in the video you saw that we were, I mean, I was just trying to jump around from one place to other, and there were a few things missing. So well, I had left few things on purpose, and the loopback advertisement of leaf 2 and leaf 3 were left out actually. So right now, I mean, if you just want to see that the whole thing is working properly, so we can say run show route protocol BGP. So in here you should be learning spine 1, spine 2, leaf 1, leaf 2, and you yourself, you don't see your loopback into the BGP advertisements. And in here, if you see run show route protocol BGP, and in here again you are learning spine 1, spine 2, and leaf 2 and leaf 3. And if you go to leaf 2, here you can see that you are learning the spine 1, spine 2, leaf 1, and leaf 3. All right, so that's pretty much it. And in my next video, I will try to do the same IP fabric with OSPF by just deactivating the BGP group of underlay, and once we have that set up, so we will basically have the understanding that we can set up the underlay network using using BGP and using OSPF. But the recommended way of setting up the underlay is that we should be doing EBGP. So thanks a lot for watching, and I would say that actually this was my first video, so maybe it's not done good, so please bear that. Thank you for watching.